Here comes the next question. A proton, a deuterium nucleus, and an alpha particle accelerated into a magnetic field with the same potential difference. Find the ratio of their radii. So this is the third radius. So third formula for the radius. We know that radius is either momentum by bq, or it is root over 2m into kinetic energy by bq, or it can be root over 2mv divided by b square q. So here they are saying they are all accelerated by the same potential difference. So here the thing that gets changed is here the root to q is not there when the kinetic energy is same, and when they are accelerated by the same potential difference, they have radius inversely proportional to square root of q, but here is not. So as we already discussed, mass of the proton mp means mass of the deuteron is 2 times the mass of the proton, mass of the alpha particle is 4 times of it. If charge of the proton is E, charge of the deuteron is also E, charge of the alpha particle is 2 times E. So radius of the proton is root over 2 into mass of the proton, voltage across which it is accelerated, same magnetic field, charge of the proton. And radius of the deuteron is square root of 2 into mass of the deuteron, potential across which it is accelerated, b square into charge of the deuteron. And radius of the alpha particle is square root of 2 into mass of the alpha particle, voltage across which alpha particle is accelerated, b square into charge of the alpha particle. When you write all these three, the common things will be cancelled. Same potential difference and same magnetic field, and then this two common thing will be cancelled. So here radius of the proton is to radius of the deuteron is to radius of the alpha particle is actually square root of mass of the proton by charge of the proton is to root over mass of the deuteron by charge of the deuteron, but mass of the deuteron is 2 times the mass of the proton. So let me write mass 2 times mass of the proton by charge of the deuteron is to root over mass of the alpha particle is 4 times mass of the proton by charge of the alpha particle is like 2 times charge of the proton, and charge of the deuteron is same as that of the proton. So proton's charge is also E. Now let's cancel the common things. E cancelled, MP cancel. Hence you have here is radius of the proton is to radius of the deuteron is to radius of the alpha particle is root 1 is to root 2 is to root 2, and 2 will be cancelled, so it is 2, so root 2. So it is 1 is to root 2 is to root 2. Or you can also multiply this with root 2 to write this as root 2 is to 1 is to 1. So we can say that what is the ratio of the proton and deuterium ratio of the radii of proton and deuterium when they are accelerated with the same potential difference means it is 1 is to root 2, and deuterium nucleus and alpha particle is 1 is to 1. So like that we can make out.